Hi everyone, it's the part number 2 of the Pressuremeter analysis, and this part I'm going to provide examples and issues you're going to encounter during analysis of Pressuremeter tests. So actually just examples and real issues or just a wrong interpretation of Pressuremeter tests. First of all, I'm going to give you some examples, whatever ASTM provides, and you can see like on left side this chart, it's the best test, like ideal test you would expect when you analyze your Pressuremeter tests. And we have like next one chapter, like not necessary. So you can see this one part, it's actually related to this part. That means in this specific case, your hole is too big. That means you cannot get nothing, no E, not E, PMT, like, nothing, and you cannot got pressure limits, no. So your hole is too big. That means test you cannot analyze, you cannot use, okay? Another option, it's like when you can see this part. That means in this case you can see, oh, this hole was too tight, too small. That means when you pushed into your this hole, your probe, you actually fail your soil during preparation stage. You understand me? Okay, so next one. So I would like to show you ideal good test. I wish all tests look like that. But in reality, guys, you not going to get every time. Maybe if it's like good person who is carrying out the test and good driller, because all tests depends literally on the experience and equipment of the drillers and experience of the person who is carrying out the test. Okay. So two test sites to carry out proper tests. Okay, let's start with bad tests. Okay, so what we can see here, okay guys, as I showed you previous slide, this test showing like a hole was a little bit tight. That means you cannot see all this initial part. Do you remember? So if it's like this one, you cannot see initial part. So question is like, where is this one? It was here or here. So I would kind of don't trust PMT models, not PMT. Maybe I could trust rebounds, but again, question marks. So guys, take into account if you see this type of tests. I speak about pre-board pressuremeters. Now, limit pressure, I just would like to show it's pretty good test, everything fine, but what I would like to pay your attention on pressure limits. So as we discussed on part number 1, you have yield pressure. So what is that? So if you have just kind of tangent to linear elastic zone, so you can take only these points into account for assessing limit pressure. That means these points and these points. And I would like to show a difference. If you just take these 5-6 points into account, and I speak about like here, I even don't speak about, I speak about like these specific points, maybe this one, yes? And you draw another curve using this point in inverse volume axis, you get increased limit pressure. So just taking another example. In this case, second example, guys, is definitely your curve even didn't start bending. That means you don't have this part. You are not sure. Maybe your linear elastic zone could continue this way. So, and that means your limit pressure is not reliable at all. Another example, oh, here guys, you even don't have, your soil even not started yielding. By the way, just keep in mind, it's happening very often in dense non-cohesive material, sand. silty sand, sandy silts, non-cohesive silts. So it's so dense, you not fail. You just densify it, period. So you don't have limit pressure. The only thing you can say, oh, my limit pressure beyond these points. It's the only thing we can, but it's like here, or it's here, or it's here. You have no idea. You cannot say it. What you can definitely say, your PMT, E naught. Definitely you can calculate and you can trust it, but not limit pressure. Another example, exactly, you don't have it. No limit pressure, guys, forget about it. You definitely have PMT, but you don't have limit pressure. And another example, sorry, in sequence, I just put in the wrong sequence. Guys, it's kind of not so bad test, but something happened like in the middle here. So you don't have nice curve. So something happened here, and like, you know, all this part of beyond, I even don't know how to assess yield pressure. If I can take this point or this point, not so good test. Not bad, but not good. And I would not trust this curve beyond this point, because actually you can see it's all sitting on the same line, on the same linear elastic zone. So I wouldn't trust, because it, I do know this specific file use some functions. And by the way, this one is the biggest problem. When you start using function, you have to be very careful, guys, because function is dummy. Input garbage, output garbage. It's exactly a good example for that. So I wouldn't trust this dashed line. Okay. K naught. Okay. So first of all, do remember, as we discussed part 1, you have tangent line. But what is happening, especially, it's very typical for Texan pressuremeter. You have this bending initial curve. It's what happened here. And what tangent do I need to draw to assess your assess our like K naught value? This one, this one, this one, guys. It's all kind of guess. So the only thing what I can say, if I make tangent line to linear, it's my kind of one option. But again, as I discussed before, there is 3 options, and I wouldn't trust horizontal stress, and which definitely I'm not going to trust K naught value. Okay, PMT. I would like to show you. So if you can see initially, I'm going to just show. They choose one and the second point for calculation of PMT models. But if you make tangent line, guys, the second point definitely off the linear elastic zone. And I don't know the reason behind that, what people picked it up. You have to pick up like this point, like for example, or let's say you can pick up another point here, but definitely not this one. Okay? And as a result, your PMT value is too low. Now, about pressure limits, you can say it's like this one, or I can extract this one, or it's again, people use some function in this specific case, and they go there. So you can get 1, 2, 3 different pressure limits. Maybe it's not big deal, maybe big deal. I have no idea. I cannot tell, like, but definitely pressure limits in these specific tests is not good. It's not reliable. It's what you have to remember. And conclusion for this specific test, let's say, first of all, as we discussed, your pressuremeter model is wrong because they picked up wrong second point. Your pressure limits is not good. Definitely ratio modulus and pressure limits not good. Your ratio between limit pressure and yield pressure not good. Your P naught value not good. So actually, all tests or analysis was test was not good. So all values, you cannot rely on them. Now, and I just would like to show you another. It was real project, and we forced consulting company to repeat, carry out the test, Pressuremeter test by another consulting company, because like it was just literally so bad tests. And look at this one, exactly the same location, exactly, I mean, with plan, at exactly the same location, plus minus half meter of the soils, and you can see absolutely different shape of the Pressuremeter test. It's good test. And definitely, now I just like to show differences. Look at this. PMT test initially was 1800. Here, 12,000. Surprisingly, you can see, okay, limit pressure kind of decent, 568, 615. But again, on the second round of the test, it's a little bit higher. And sometimes it's very important if you need more bearing capacity. The same site, the same, it's even worse. And again, consultant produced some results. And this one, another consultant used exactly the same location, exactly the same depth, plus minus half meter. Look at this. Again, you have 2000 Pressuremeter models. After it was redone by proper way, you have 18,000, almost 10 times. Again, like limit pressure was not so big, but again, you have 558, 600, so 100 kilopascals. So it couldn't influence on your eventually bearing capacity, okay? And I just would like to discuss one more issue. I don't know why ASTM standards doesn't talk about that. And like when I carried out all tests and we discussed with professors, definitely we took into account groundwater level. So what happened? What I'm showing right now, it's 4 tests from the same borehole, and you can see every time initial stress here. If you just, I'm just going 1, 2, 3, 4. So every time the deeper you're going, the higher initial pressure. Guys, and it would be absolutely correct if the deeper you're going, the high initial pressure of the test. It's totally correct if you doing your test in dry borehole. That means you have clay, for example, and you doing your hole by auger, small auger, totally fine. And definitely the deeper you're going, the high initial pressure is going to be. The reason why behind that, very simple. You have hydrostatic pressure, hydrostatic column in your tubes. That means the deeper you're going, the higher initial hydrostatic column you have. And definitely it started from not zero, not origin, it's shifting. But guys, if you using drilling mud, or you drilling like your groundwater table, let's say, kind of example, at the ground surface, so what is going to happen? Actually, your hydrostatic pressure column inside the tubes of your equipment, and hydrostatic, like your native, if you're drilling with drilling mud, it's at the surface. So what is going to, it's absolutely wrong, because you get some minor differences, maybe 10, 15 kilopascal, but not, let's say, 100 or 200 kilopascals. And that means, again, your curve should start from origin, and it's every time make wrong assessment your horizontal stress. Guys, so keep it in mind. Please, I don't know why consultant companies don't do this correction. If you drilling with drilling mud, it should start from the same point, period. Like, I mean, very rough approach. You definitely can calculate. Maybe you can get some 10, 15 kilopascal, no problem, but not 100, 200. And you can see here, it's like 1,000. So it's 1,000. So you can say 300 kilopascal, and no reason behind that. Why? Because these tests were carried out with using drilling mud. Okay, again, thank you very much. The second part of Pressuremeter analysis. And again, guys, coming soon, like I'm going to make website, you can see different types of presentation, and you can ask questions LinkedIn. Thank you very much. Have a nice day.